Okay, so welcome everyone. We are in week 5. So today we are going to start a new chapter, chapter 3. So we will talk about the relational data model. Not most of them, but some of the things that we are discussing today, we already talked about it, but today we are going to go through more details about those. And then uh, this chapter is so important, especially the next session, which we will talk about the normalization. So by normalization, we already talked about it a little, why we need to have the normalization process in the relational data model. So we explained that, for example, if we have one table, for example, with the customer information, the sale information, the same example that I'm using multiple times, that my name there as a customer. So if I have, for example, thousands of transactions, so they have to repeat 1,000 times my name. So instead of that, we can have a new table and then just inserting my name once, and then they're gonna just address it with the ID. So that's the process that we are trying to have as much as efficient as possible. Number of table relation with some specific condition. We call that one normalization. We will talk in details on Wednesday, but today we are gonna go through the some concept of the relational model. We will talk about the relations, attributes again, domain. What does it mean by domain? When you're talking about when you're talking about it in the database management system, and then we will talk about some specific concentrate that we have. So entity integrity and referential integrity. We will talk about those. And then again on Wednesday, we will start talking about the normalization process. So let's just have a little history of the database management system. So just make sure to read the book about it. It doesn't anything special, just it's good to have some idea. So before all of this logical design of the database management system, which means all the uh, structured database that we have, that then we can, for example, use the SQL in order to have the query. Previously, before these, we had all things on a physical systems. It wasn't based on the uh, database management system that we have right now. So back then, it was the disks. So they had to store data on those disks, and they had to address, for example, some related data between some disks to other disks with something that we call them as a pointers. So as we can easily see that there was a lot of limitation with this, and also a lot of issue. For example, if they were supposed to update this physical database, they had to change the disk, and there was a lot of physical threat to the disk. So wasn't good at all. So then after all this limitation and issue, this person, Mr. Cott, Edgar F. Cott, so technically he's the father of the database management systems that we have these days. So he came with this idea of the logical design instead of having a physical design. And then based on what he presented, so technically he provided the basics of the database management systems that we have, and SQL that we have technically comes from this person. So if you are in this class and enjoying this class because of this person, so Edward F. Cox. So let's talk one more time about all the relational databases and start with the relation. So what we called as a relation, which we already discussed about it. So what is the exactly relation to you after these couple of sessions that we had? Table, simple. The table that we put all the information to it, we call it as a relation. That's why we call it relational database. So technically, there's a relation between these uh, relation table that we call it. So each table, just as a example, the first example that we had, which was the book and the author. So the example that we always have. So this one, the book, we call it one entity, and then all the attributes, all the features of this book, we are putting it in a table. So that one, we call this one as a relationship. Technically, in this specific database system, we can say that we have only two relations. And based on the relationship between these two, we have the entity relationship diagram, or ERD, which we'll discuss about it later more. So technically, each relationship is the table 2 by 2, and so technically just multiple rows in multiple column, and each column we call it as a attributes, features. Again, whatever features could specifically describe one single entity. We have to go through it, details of the business that we are supposed to work, and see, for example, in which section, in which department, in which specific area that we are supposed to have the relation, what are the features? And those features should completely describe that specific entity. We should avoid extra features, we should avoid extra attributes, and we should make sure that we already addressed all the necessary attributes, all the necessary column features for the entity. And one thing that the order doesn't matter. So for example, for the customer table, if you put the customer ID in the first column, it doesn't matter. If you change it to the third column, fourth column, it doesn't matter. The order doesn't matter, but as we know, the column names should be unique. So you cannot have two, which is obvious. Two, for example, same name for the two columns. And then for the rows, that we call them as a each row of the data, each record, we call it a tuple. Just the name, doesn't matter. We call it as a tuple. So each tuple, each row, each record of data. That's it. Customer ID 1, related information. Customer ID 2, related information. Customer ID 3, rest of the information. So it doesn't matter. Again, same as the attributes, the order doesn't matter. At the end of the day, it doesn't matter which rows you should insert first, okay? So that's called as a tuple, as a row, as a record of the data. And the only things that we should always make sure that there shouldn't be any exactly same information for each row. It should at least have some difference, which is the primary key, which we will talk about. The other things that is important is domain. So what does it mean by domain? For example, we have multiple, again, attributes to the table. One, first name, last name, social security number, phone number, address, all the things, okay? So the, let's say, yeah, the nature of whatever is underneath of each column, it should be the same. If we are talking about the SSN, so technically we are inserting some numbers here. So we cannot, for example, having some numbers and the other rows should be some characters or something. Because we will see later when we are trying to create this table, for example, for this SSN, we would say, okay, just make sure to put the integers. Or for example, if we are putting the first name, last name, we would say the nature of this column is the character, okay? So then we can do the rest. So technically the domain describe all the columns information, they should be in the same domain. That's it. So for example, we can have two columns that they have the same domain, first name, last name, they're using the character, but their name should be just different. So right now we can see here that just as a simple table that we have. So right now, columns or attributes, course ID, department, course number, course title, credit hours. And then we have three technically tuples or rows to records of data. And for the domain, again, here for the course number, we are using just numbers. For the credit hours, also we are using numbers. They have the same domain, but different column name. And the last one, which is the null values, which we talked about it last week. So by null values, which means we don't have access to the information. It doesn't mean it's a zero or it's a, I don't know, anything. It just means we don't have available information for it. That's it. And we mentioned that when we are trying to, if you already started the assignment 2.345, so when you are inserting some data to the table, so for the values, when you are putting null, do we need quotation for it, or we don't need to have the quotation for it? We don't. Because when we put the quotation, this one considered as a string. So technically, the value over there is gonna be null. Like, I don't know, my first name, Hossein. So that's a point. So you need to make sure always not have the null. And you already saw when you put just the null, the value is in a blue color. If you put the quotation, it's gonna turn to the black color, okay? So that's the important thing about the null values. And the way that we also write it in just English is important, okay? So in this case, when you're addressing an entity, a relation in your database schema, you should always start with the table name and then parentheses, the first attribute, attribute 1, attribute 2, whatever. And then for the primary key of that specific table, you just need to underline it. That's it. So for example, in this case, for the student table, we just need write it as a student, parentheses, student ID, student number, first name, last name, serious address, city, and the cell phone. And here, a student ID is the primary key. We should put the underline to it. Since we are talking on for the primary key here, that's why we don't have underline here. So, but we see here as the underline. So let's talk. Any questions so far? So as you already noticed, most of them are the things that we already discussed. We are just went a little further to be more deep. So what is the key? What is the primary key in the relation in the table? Please tell me. Is the primary key in the table?
Usually
Unique, yeah, unique identifier of that table. Okay. So technically, we can have a table with multiple primary key, with multiple keys, sorry. But you need to decide which one should be a primary key, the key that you are gonna work with that one in your database, okay? So technically, for example, in this example, in the course ID department, course number, course title, credit hours. So here, the one that's really eligible for key is a primary key is the course ID because it's a unique one. For department, it's not unique. For the course number, for sure, it's not unique. But for the course ID, we can see there are just a unique number for the courses. So technically, if you have a table, if you're designing a database, if your table doesn't have any attributes, any features that uniquely describe that specific entity, you're doing definitely wrong. So you have to have exact at least one features, one attribute that technically is unique for that specific entity. So as I mentioned, we can have multiple key that describe the entity. We call these as a candidate keys. So we can have multiple keys. Again, each can uniquely describe that entity, but the one that you are choosing to continue work with as a unique identifier, we will call it as a primary key. Okay, so we have multiple keys, candidate key, but the one that you are choosing it as a unique identifier, we call it as a primary key. There are also other keys. The third one, which is very important to know, we have the as a composite key. Okay, so when two keys, each one itself, they cannot be a representative of that table, but when they are combining together, both can be considered as a one unique identifier. So technically, the composite key could be two attributes that working together, and they're gonna be a representative of that table. So that one considered as a composite key. We will see some example about it. But do you have any example in your mind right now for some whatever entity that you can just imagine? Let's think about it in a, for example, academic that we are working. We have the faculty table, my information, class I'm teaching, you as a student, class you are taking. Do you have anything in your mind that could be a table that both of these could be, for example, unique? Together, they're going to be a representative of that. You know, let's say, for example, enrollment table. Enrollment table could be your student's ID and the course ID you have, okay? Each one itself, they are not representative of that table, but your student ID and the course ID that you are taking together, these two can be considered as a composite key. Because in that case, that specific row is gonna be unique because you are only taking my class once. You can definitely have other class as well, but your name, and the students and the course ID together is just happening once. So technically that row is different. Agree? So that one comes as a composite key. Composite key is very important concept to know, especially when we are dealing with the normalization on Wednesday. Technically, the second form of normalization, we should make sure to not violate the composite key concept. We will talk about it. The other type of key, we call it as a surrogate key. Surrogate key is just some identifier number, which they don't have any real world representative. Some number, like a student ID, like my employee ID here. So they are just number, they are generating by the system just for me, just for you as a student number. So technically that one could be also considered as one of the keys that use it, which is very, very helpful because at the end of the day, this one could be unlimited. Certain number of the numbers, certain order of the numbers for thousands of the students. So we can have as much as we want for the as a ID, as a key. The other one, which we can have as a key, we call it as an external key. External key, they have the real world instances. The most famous example is our social security number. Our social security number in a real world, there is a representative for us. My number represented me. Okay, so that one also comes as an external key. So these two can also used in a database, but usually people use surrogate key because they're random number generating the system and it's easier to work with. So that's about the keys. Any question regarding the primary keys? No. Good. Let's talk about the foreign keys. So about whatever we already discussed. So what is the foreign key to you right now? Based on what we talked about, the how we can connect two tables, two entities, two relations together. So what was this? No, I mean as a definition of the foreign key. point is the primary key of the one table exists in another table, so that one considered as a foreign key. So technically, when you are trying to connect two tables together, two relation together, you should use one primary key of one table as a foreign key in another table. And if you are designing a database that there is no foreign key in your database, technically you are doing wrong, because in that case, how you want to connect these two tables together. So one more time, this example, the sale table, for example, have the customer ID and the rest of information, and then let's say also sale ID, and then the customer information, customer ID here. Okay, so the sale ID, the primary key for sale table, the primary key for sale table is a sale ID. Okay, whatever. I purchased some items from this company. My ID is 2, your ID is 3, 4, rest. Okay, and then we have the customer ID table, which is again my name 2, your name. So information are here. If we don't have the customer ID here, technically there is no way that we can connect these two tables together. Is there any way you think? Is it? Is there? How you can? Oh, because you just okay. So technically, there is no way that we can connect these two tables when we don't have customer ID together on this table. That's the only way that you can join these two tables together. So, for example, in customer ID 2, there is a one exactly value for it with my name, my information. That's how you can connect these two tables together. So, for example, customer ID 2 purchased this item with this information. So this customer ID in this table considered as a foreign key. Okay. Any question regarding the concept of foreign key and primary key? Because these two concepts, even though it looks simple, it's important again in the normalization process. You have to understand it very well. If you think it's not clear enough, let me know. I can explain it again. All good? For sure. So again, the most important part of using the foreign key is to trying to find the connection between two tables. That's why you are using primary key of one table as a foreign key in another table. Okay, and we can have a table that can have multiple foreign key, which is totally fine. Because, for example, one is for the customer, one is for the, I don't know, let's say product table. So you can have those in a sale table as well. So technically, you can have more than one foreign key in one table. Okay. In this example, so we have the student table, which is the student ID is the primary key and rest of the information. Course table, course ID is exactly the one. And then grading course table, which is considered by the student ID and the course ID. Okay. So here, in this case, a student ID and course ID, which is a composite key in this table. Right now, we can have the student of the student as a foreign key from the student table and course ID as a foreign key from the course table. Okay, so technically each foreign key you can just refer to the other table with using this foreign key in the second table. In this example, yeah, these two are considered as a composite, because again, just the student ID itself cannot represent. So, but that's not the case in this one. The only thing that matters here is using these two keys as a foreign key in this table, okay? So the example that we have, yes, the primary key of this table is student ID. That's the way that we can also see in a relational database model. So a student ID key, course ID key, these two together, the composite key in this table. And then again, here you can see that this one foreign key references the primary key by the arrows that we have. So that's the Redcat database that we are using, part of it. So right now, again, sale ID for the sale table. The primary key is the sale ID. Over there, customer ID. Here, the product ID and manufacturer ID. But the point is, sale ID has also customer ID and product ID. So technically, these two considered as a foreign key in this table. And this table, customer ID, first name, last name, street ID, DD. And then here, the product table and the manufacturer ID. Again, the manufacturer ID here already has that primary key as the foreign key here. But one of the points about this primary key and foreign key is to make sure to not violating these two rules. The first one, which we call it as entity integrity. By entity integrity, it exactly means that the primary key that technically they are supposed to be in a table in order to uniquely identify rows in a table. We should always make sure there is a value for it. If there isn't, we are not supposed to, we are not allowed to have the null value for the primary key, which is makes sense. Because if you have the only, if you don't have a value for the primary key, so how you would like to address that specific column, that's a specific row, that's a specific tuple. So for example, in this case, if I have a student ID as the null, as a don't have information for that one, how I'm supposed to address this second row, this second tuple. So that's the one of the first rule that you need to make sure to not violate. The primary key should always have value. That's why maybe using the surrogate key is so good, because it will automatically generate the key. So we will say in a create, especially when you are designing, for example, with the access your database, you are just giving this information to the software that, okay, use the auto key and it's gonna just generate automatically. So you will make sure that each rows, each tuple, they have exactly value for the unique identifier. Okay, so entity integrity is the one of the first rule that we need to make sure. So these two rules and the following rules that we are gonna work on Wednesday. So those together, we are using them in a normalization process. Again, by normalization process, we will see more on Wednesday, but we are make sure by not violating these rules that our database work well, in order to not having data redundancy, in order to not having any missing values. We will see more on Wednesday. The second one, referential integrity. Let me read it from the text. Every foreign key, just read it by me. Every foreign key, which means the primary key in another table, must either be null or must be an actual value of a key in the reference location relation. So right now, here we have a student ID, course ID. We know that these two from the previous slide, these two are the foreign key, okay? So here, the course ID 8, just considering this one as an example. If I go back to the database, there is no course ID 8 here. So technically in that table, course ID 8 is telling us something which is not available in the referred relation, okay? So this is wrong. We are violating the referential integrity. So if I have ID as a null in that table, is fine, okay? Because in that case, we are not addressing anything. But when you're addressing something, it should be available in the original table, okay? One more time. Again, let's read together. Every foreign key must be either be null or must be an actual value of a key in the reference relation. In this example, this table, we know that a student ID, course ID are the foreign key from the student ID table and course student table and course table, okay? Here we can see that a student ID took course ID 8. When I go to the original course ID table, there is no course ID 8 here. So technically that table is referring something which is not available, at least in this example. So if that ID was null, it's fine. We are not addressing anything. But when we are addressing something, it should be available in the original table. Okay? So now, any of you just, again, could tell me what does it mean by referential integrity, because it's so important. Please. Yes. Yeah, exactly. Simple. Whatever you are referring to that one, it should be available in the original table. If it's not available in the original table, you are violating the referential integrity. Okay? So that's why referential integrity, it's important. Again, we will see on the normalization process how this one is important. Okay? So let's me open this one as an example. Okay. So let's, in this example, identify the primary key and the foreign key, and then together we can create a schema for it. By a schema, which means just table name, parentheses, and the relation. So in the first table, which one considered as a primary key? Employee ID, employee name, employee address, employee phone, position ID, location ID. So employee ID could be considered as that. And in the second table, position table, position ID. And the location ID. And what are the foreign key in these tables? Foreign key. Which table has the foreign key? Employee table, how many foreign key does it have? 2, which is the position ID and the location ID. So this is the way that we write it. So that's one way to represent a database system, which that's in a real world, after finding all these attributes and trying to describing the database. So this is the way that they first write it, and then according to these, they're gonna create the database, doing the syntax, SQL, and running all the related stuff. So again, employee ID table, employee table, which all the related attributes, and the foreign key, both. So the first one refers the position table, and the second one represent the location table. So most of you have already a paper. You don't just try to think on your side. So a university database tracks information about the students ID, name, major, phone number, then professors and the rest, and the section. So we need to have the relation for this database and a schema of the relations that we have. So right now in this one, let's have it as a relational data model. So the first relation is a student. So the first one start with ID, then name, then rest. Okay. So for sure, ID is the one that we are choosing as a primary key. Just consider this as a key. And the other table is the professor table. So again, ID, name, and the rest. This one is also considered as a key. And the other table, course table. Let's name it as a FID, SID, course ID, and the number title. So technically, these are the table that we have in this specific case. So the student table, professor table, course table is the one. And then we have the section table, which is the again section ID, course ID, section number. And then we can have another table, which is the enrollment. Okay, so enrollment considered a student ID and the section ID. And it could be also the rest of the information, but these two just enough to represent this table. So technically, these two has the foreign key from those tables. So this one, section ID, references the section table, a student ID references the student table, and together these two considered as a composite key in this specific example. Okay. So this is also the way that we write it as a database schema. So just table name, information, or whatever relation that we have in this table. And then if there is a foreign key in those tables, we have to address those foreign key. That's the way that we write it in a database schema. Another example. So this donut organization store orders several products from various vendors. They have contact person on each vendor site along with all address information. Each purchase order has the order number, date, tax, there's product information also. So Donut sends a check for payment and record the check date. Create a set of relation for this database and a schema for the relation you build. So just 5 minutes, try to think on your side and try to address it with the tables. And if there is any more tables that you need to have, like the enrollment table in the previous example, make sure to put it there. Some transaction is happening here. There are some payments that's sending to the vendors. So specifically for that one, we need to have a table just as a guide to you. So just from the question, we can see we can identify multiple relation, multiple entity to this one. Am I right? What are those? What are the relation? What are the table name that we can have? The first one, the vendor. We have some specific information. Vendor, so vendor is one relation, one table here. The other one, order. What did you say? Order, purchase. We name it order or purchase. Doesn't matter. Yes, purchase order. And the other product table is also the one. The product order is also the payment is the one that we need to address extra. Yes, you're right. Payment is the one that I wanted you to address it, which you did. Thank you. So the payment also is the one that creating based on these relations. So we need to make sure to put some specific key to that one. So at the same time that you're drawing, try to find the connection between these as well. That would be great. You can also determine what are the relation between these. So the vendor table, vendor number, vendor name, rest of the information, order table with the order number as the primary key, the product table, stock number as the primary key, and the product order, which is again the order number, stock number, and the payment table. Okay, the payment table as the primary key as the check number, the one that they are issuing to the vendor. Okay, so that's the way that we will call it as a database schema. So for the vendor table, we just have one primary key, and order table, order number, and the vendor number and the check number considered as the foreign key in this specific table, and product table, product order that we have, and then the payment table. So here we have to have the underline for this. And the last one, check number and the check date. So this is the way that we write it as a database schema before creating these information, changing this information to the real table with the SQL codes that we already saw some of them. Any questions so far? No, it's
companies get like, they hire people to do this for them.
Mhm.
That's a whole job, right?
That's the whole process. That's one of the part of the process of the creating a database system. Yes, this is one of the most preliminary stage before creating the real database with the SQL code. There are some people, maybe sometimes other people, that work on that organization to reach these information. Sometimes depends on the company scale, could be different people. Sometimes it doesn't worth it to have two different teams. So just one team do their whole process. And also sometimes they just do the purchase some external database system with some available information. It depends on the organization for it. The only thing that matters for us at this moment is to write about database schema. That's the way that we are writing. And then how we can transcribe this one, translate this one to the SQL code. Okay. So for example, for this one, for the first one, the function for it, we will see later. We have the create table. We saw it in the assignment 2.345. Did you see the announcement I posted for the 2.3, 2.4, 2.5? Did you see the assignment, the announcement? Yes. So I just put some clarification what you need to do for running the assignment 2.3, 2.4, and 2.5. So Let me go through the book. So make sure to read these pages through the book, especially the first one is just the history of the BBMS that we taught. Here at the last part, there's something that we call it as a recursive foreign key. Okay, we will see this one more in chapter 5 and 6. We will talk about it more. But what does it mean by recursive foreign key? We have employee ID, okay? I, Hossein, here, let's put as an ID. And I don't know, first name, last name, employee ID, okay? I have some information here. My employee ID, my information. Am I right? Okay. My boss, my department chair also is available in this table. Agree? Yes. His boss, the college dean, Dr. Robin Shreni. She is also available in this table. Am I right? Her boss is also available in this table until the president of the Kennesaw State. Okay. Technically, this specific entity, employee table, there is a recursive relation between this entity. I am reporting to my boss, he is reporting to his boss. So the way that we can refer each other, it comes from only one table, okay? So we are not addressing any other table. The relationship between me and my boss is through the employee table. Employee table has both of us information. Just right now, keep this one in your mind. We will talk about it later, especially in chapter 5 and 6. But that's all I need you to know at this moment. What does it mean by recursive relationship? The entity has the relationship with itself. Most simple example is through the employee table. I am reporting to my boss, he's reporting to his boss, and the rest of the process, okay? So technically this table trying to, let's say, addressing to each other just as a recursive relationship between this table, okay? So on Wednesday, on next session, we will talk about the whole normalization process, the first normal form, second normal form, third normal form, and sometimes fourth normal form. And that's the very, very important things to learn, because if you don't go through these conditions, these rules, definitely your database gonna have issue later. So you need to always make sure, and they are so simple. They are not a very scary thing or something. They are very simple. We will see on Wednesday. But after going through these, then you can be 100% positive that, okay, my database is not creating extra data, is not having misleading data. All the referential integrity is addressed, everything. So some rules that we will see, and it's, I would say, fun to learn. So if you don't have any question at this moment, let me stop the recording. Mm. Okay, welcome everyone to the second part of the lecture for this week. Today we are gonna finish the chapter 3. So we are working on normalization and continue to what we discussed on Monday. So let's start with the normalization. So again, the same example that I've already repeated multiple times. We're gonna have it one more times again, in order to understand why we need normalization, why we need table decomposition. So we will see. So the example that I already mentioned multiple times was that, for example, we having this sale table with the first name, last name, and rest of information. My name there, Hossein Mohit, as one of the customers. So imagine I am purchasing thousands items in a year from that company. So they have to enter my name 1,000 times. So if they put my name wrong, they have to go and fix it 1,000 times. So that's a lot of data redundancy. So we mentioned in order to address this issue, we can have one extra table as a customer table. We can put the ID 1 for the Hossein Mohit, and each time instead of inserting my name 1,000 times, so we can just put my ID, which is ID 1. So technically, in this case, we are inserting my name only one, and there is no extra data, no waste of time, no waste of energy, no waste of memory, anything. Okay, so that's what we need to have the normalization. So by normalization in a database, when we claim that our database is normal, which means there is no data redundancy, there is no further issue by adding data, there is no further issue with the updating data and deleting. So all these anomaly that could happen because of the not having a normalized database, we are gonna address it. So in order to be in a normalization process, we need to go through three different standards. We will see them. So if you remember, we started chapter 2 with the first table, which we call it simplified sale table, all the information, and then we came to the conclusion, okay, we have to have multiple tables. Okay, so that's why for the rest of chapter 2 we worked on different tables that the combination of these tables together, we call them as an entity relationship diagram. So there is a relationship between each of these tables, each of these entities, each of these objects. Okay, so now let's go for designing a database. Then at the end we can claim, okay, we have a normalized database. Okay, so we will start with one important definition: functional dependency. We have to first understand this one, and according to this we will go through the first normal form, second normal form, and the third normal form, which is the most important one, is the last one. So by functional dependency, imagine, for example, we have A to B. So in this case, we will say A determine B, okay? Or B is dependent to A, okay? So let's go back to this example. Here, we have sale table. We have sale ID as the primary key. Sale date, customer ID, product ID, quantity, tax, shipping, all rest of the attributes, rest of the features in this table, okay? Do you agree if I just have sale ID, for example, sale ID 100? If I go to this table, I can see the rest of the information. Yes. So technically by sale ID 100, I can determine the rest of the attributes. Okay. But if I have just, for example, February 2, 2024, can I determine the rest of the information? No, because for sure for the February 2nd, 2024, maybe there would be thousands of transactions, thousands of rows. So technically, we cannot determine the rest of them, okay? So unique identifier, that's another case for it. When we have the unique identifier, according to that one, we can definitely determine the rest, okay? We call these things as a functional dependency. So technically, for example, when you have the manufacturer ID, you can determine manufacturer state, okay? And we can say that the manufacturer state is dependent to the manufacturer ID. okay? And we need to always make sure that when we are saying X determine Y and Y dependent to X, okay? So the item on the left side, we always call it as a determinant, okay? So this is a general concept of functional dependency. We will see how we can use this in the second normal form and the third normal form. So any question regarding the concept of the functional dependency? Is it clear? What does it mean? No question? One more time. When I have sale ID, for example, I can determine the price of that specific transaction, okay? So price here is dependent to the sale ID, okay? Sale ID determine price. Price is dependent to the sale ID. So that's the functional dependency. Now we know what does it mean by functional dependency. Okay, am I right? So let's start the normalization. So we have first normal form, second normal form, and third normal form. Okay, these three are the most important thing for us when we are talking about the database normalization. Okay, technically we will see when our database is in the third normal form, automatically address the second and the first normal form. So when we can claim that our database is in the third normal form, we are good to go. So we can say, okay, now we have a normalized database. Okay, one more time. The main reason for having a normalized database is to avoidance of any type of data redundancy, any type of anomaly when we are inserting data, deleting data, and updating data. Okay? So let us start with the first one, first normal form. For being in a first normal form in the database, there is a one single rule, which is all attributes in a table, all columns in a table, they should have only one value in each cell. There must be atomic, which means in this case, employee name John, Mary, Luan, the name is just one. But when I go to the skills, we can see there's a programming, there is a query optimization. This is wrong. We can only have one value. We cannot have two values on each column. In this case, we can say this database is violating the first normal form, okay? So in this case, we have to address it like this. So we can have the John, and we can have the skills in the two different rows. So that's the only way that we can address this issue. So one more time, in order to be in a normalization process, in order to claim that, okay, we have a normalized database, we have to go through three different conditions. First normal form, second normal form, and the third normal form. Now we are addressing the first one. By first one, which means all the values under column, under each attribute should be only having one attribute, one value, not more than one. So right now, programming and query optimization is wrong. But maybe you would say if the name has two parts, it is fine. That's the one name has two parts. Like for example, some Persian name that has two parts. But here we can see there is two different value under the skills column. So this is the first normal form. If you have multiple values, you are violating the first normal form. Okay? So this is the first one. Was it easy? Yes? Simple. Just by reading the data, you can very quick understand, okay, there is a multiple value, so now the first normal form is violated or no, it's checked. Let's go to the second yes. What is the Okay. Oh, where is it, you mean? Oh, we just didn't put it. We have John Mary. So because we didn't have more space, yeah, we can have Loan, and for the Loan, we have to have 3 different. Okay. Good eye. I didn't check. Now let's go. Okay. This is the table that we have. What is the primary key in this table? Is the student ID primary key here? Okay. So can we say that just by having the student ID, we can identify each row? But if I have a student ID, which is, what's your name? Mario is the student 1, okay? And what if you have another course, which you have multiple courses? So if I just have your name, can I determine exactly which row is related to you? We can't, because this one uniquely is not going to uniquely address each row. But when I have the combination of the student ID and the course ID together, we can say we have the unique identifier for the row. Okay, one more time. A student ID 1 can have multiple courses, am I right? So a student ID 1, fourth row, can have, for example, course ID 8. If I just have a student ID 1, am I able to say which row I'm addressing? No, because row 1 could be the one, row 4, row 5 could also be the one. But if I have the student ID 1 and the course ID, you cannot take one course 2 times in one semester. So a student ID 1 and course ID 7 uniquely describe the row. Okay, so we have the composite key. Am I right? So what was the composite key from the previous session? What does it mean by composite key? How many key we had? So the combination of 2 keys together, they can be a primary key. So each can be a candidate key, but together they are describing the whole data, the whole row. So they are technically, the unique identifier is the combination of the 2 or more than 2 keys. It's not just, it shouldn't be just 1, 2, exactly 2. It could be more than 2. So in this example, when we are talking about the second normal form, let's read it from the first line together. No non-key attributes. Non-key attributes, which means in this case, the student name, credit hours, and grade. Am I right? Because student ID and the course ID are the composite key. So the non-key attributes here could be a student name, credit hours, and the grade. No non-key attributes can be functionally dependent on only part of a key, which means when we have the composite key, here we are talking about the functional dependencies that we just learned. When A determine B, okay? So here, imagine the A is the primary key. Now we have, for example, A and C determining B, okay? This is the composite key. So technically, if we have a composite key in our database, the dependent should depend to the both of them, should be depend to the whole composite key, not only part of it. If it just depends to the part of it, it's a violation of the second normal form. Let's see from this example. Here, if you have the student ID, you can determine the student name. Am I right? Yes. If I have the course ID, I can say what is the credit hours for it. Yes. The point is, here, if I have the student ID and the course ID, I can say there is a grade. But the issue comes from the credit hours is just dependent to the course ID, is not dependent to the student ID. Again, one more time, we have the composite key, a student ID, course ID. No non-key attributes, which means these three. They should be dependent to the whole key, not part of the key. Okay? Here, the credit hours is just dependent to the part of the key, not the whole key. That's why we have the violation of the second normal form. One more time. When we are talking about the second normal form, most of the times is more related when we have the composite. What does it mean by composite key? When we have more than one key to combine together that they can describe uniquely the table. Okay? There is a rule. No non-key attributes. So whatever attributes that are not key. Here, a student name, credit hours, grade. They should be dependent to the whole key, not part of the key. Here, credit hours is just dependent to the course ID. It's not dependent to the student ID. Okay? So technically, credit hours is just dependent to the part of the key, not the whole key. That's why we have the second normal form that is violated. Clear? Yeah, go ahead. Dependent. So be so when you're talking about the let me tell this way if I understand your question correctly. So in this case, we said A determine B, okay? And B is dependent to the A, okay? When we have multiple keys together as a composite key, this B should be dependent to the both, not part of it. Here, yes. So in this functional dependency that we are writing here, we are first trying to say what are the functional dependencies in this table, regardless of anything. In this table, if I have the student ID, just rationally, we can see what is the student name, okay? If I have the course ID, I can say what is the credit hours. If I have a student ID alone, I cannot say anything about the grade. Am I right? Because the students can have multiple courses. So if I have just your ID, I cannot say which course and which grade. So the combination, if I have your name, if I have your name and your course ID, I can say, okay, B plus is your grade. Okay. So first of all, this is the functional dependency in this table. Nothing related to the second normal form. Now I am just going and check, and I'm seeing that credit hours is just dependent to the course ID, is not dependent to the both together. In that case, I can say, okay, this is wrong. So one non-key attribute is dependent to the part of the key, not the whole key. Okay, we will see more example, especially at the end, we will work on some assignments, so it's gonna make more sense for you. But at this moment, that's the rule. Remember, practice, you will learn. No non-key attributes can be functionally dependent on only part of the key. Okay, good. Is it clear already? Yes. And just by practicing more, definitely it's gonna be better. But at this moment, let's go to the uh, third normal form. But just for the violating, the data redundancy, insertion anomaly, updating anomaly are the issues that could happen. So right now, in order to fix this table, we should decompose the table, which we call this process decomposition. We should decompose it to 3 different tables. One table, just a student ID, a student name, okay? We have one primary key, and this one is already dependent to it. Course table, course ID, credit hours, dependent, and then the last table, which is the student ID and course ID, which is the composite key, and grade is dependent to the both, not only one. That's the right table. If I have the grade B+, so this one comes from the combination of the student ID and the course ID. So this means this one is dependent to the whole key, but nothing part of the key, not part of the key. Maybe now it makes more sense when we are decompose the main table to 3 different tables. All good? Yes? If no, ask me, please. I would be more than happy to repeat it again. So we'll work on it more on the assignments as well. So the third normal form, the most important one. If your table on a third normal form, technically you can claim that your database is normal. Okay? So what was the functional dependency? A to B. A determined B, B is dependent to A. Am I right? Simple. The left one should always be a primary key. That's the simple rule. If this is not the primary key, there is a violation of the third normal form, which means all non-key attributes, which means those attributes that are not primary key. We have one primary key or maybe composite key, whatever that are not non-key attributes. They should dependent to only primary key. If you find some functional dependencies in your table, for example, X determine Y, if this one is not a primary key, there is a violation of third normal form. Okay? See the example. The table is employee ID, skill type, and bonus. Okay? So employee ID determine the skill type and bonus. Am I right? If you know the employee ID, you can see who is the employee, what is the skill type, what is the bonus. Also, if you know the skill type, you can determine the bonus. Okay? Logically, based on this example. So technically, there is a functional dependency between 2 non-key attributes. Skill type, is the skill type primary key? No. Done. We are violating the third normal form. That's it. Okay? Let's see another example. Again, the issue just with the data redundancy, updating, and deletion anomalies. So in order to address it, we have to decompose the whole table to 2 different tables. First table, employee ID skill type, and the skill type for the primary key of the skill table and the bonus rate. Okay, let's see this example. We have a table called employee table. Okay, employee ID, employee name, department ID, department name. So let's check the first normal form. Is there any issue with the first normal form in this table? So what was the criteria to say that we are making sure that the first normal form is not violated. What? Sorry. Atomic values, which means we shouldn't have multiple values under the column. Do we have? No. So technically, this table is in the first normal form. Is it clear why this table is in first normal form for everyone? Okay. Now, the second normal form. So this table, employee ID, is the primary key in this table. Do you agree? If I know your employee ID, I can say what is your employee name, which department you are working, and what is your department ID. Am I right? Correct? Correct. So technically, the second normal form is already also okay. So we are not violating the second normal form. However, there is another issue. What is the issue in this table? First of all, there is no composite key here. So we mentioned second normal form most of the times happens when you have the composite key. When you have the composite key, all non-key attributes should be dependent to the whole key, not part of the key. Okay, here there is no non-composite there is no composite key, so technically we are good with the second normal form. But there is another issue in this table. What is the issue? Check the functional dependencies in this table. So tell me. Exactly. So when you have the department ID, you can determine department name. Department ID, is it primary key? No, done. We are violating the third normal form. Easy. Okay. So in order to address, we just have to decompose this table to two different tables. One table, employee table, one table, department table. Some minutes for digesting concept. Let's starting again. Normalization process. Why we are doing the normalization process? Because we are making sure to avoid any data redundancy, any type of anomaly in when you're updating data, deleting data, or inserting data. Okay. Example, the customer table with my name, then we change it to the customer sale table with my name, then we change it to the customer table, give my name and one ID, and repeat that ID to the sale table. Okay. So in order to be in a normalized data, we should make sure that we are meeting these three conditions. First one, first normal form. First normal forms, atomic value, which means there shouldn't be any multiple value in column. That's it. Second normal form. All non-key attributes should dependent to the whole key, not part of it. Okay. Example we had here. The credit hours is only dependent to the course ID. It's not dependent to both together. Then we decompose it to these three different tables. Now grade is only dependent to the composite key, not part of it. And the last one, third normal form. All non-key attributes should dependent to the primary key. And there shouldn't be any other functional dependency in the table, okay? So which means if there is a x to y, which means x determine y, x always should be a primary key, okay? In this example, department ID, when you have it, you can determine the department name. So technically, there is a functional dependency in this table that the determinant is not primary key. So that's the violation of the third normal form. So if you just remember and memorize these three lines, you are gonna be okay when you are designing a database. Let's read together. All attributes in one table must be dependent on the key. The whole key, nothing but the key. One more time. All attributes in one table, they must be dependent to the key, the whole key, nothing but the key. Okay? So when we are saying all attributes, imagine we have a table X, Y, Z, double. X is the primary key. Okay? Okay? So let's put X and Y as a primary key, as the composite key. Okay? So right now, all attributes in one table, Z and W, should be dependent to the key, the whole key, and nothing but the key. So there shouldn't be any connection between W to Z or Z to W. Okay? So just by memorizing these sentences, you are good to go. So you can say, okay, our database is in a third normal form, so I am good to go. There are other normal forms, but technically, when you're in the third one, you're done. But the last one, fourth normal form, technically it's, let's say, there for having more efficient database. That's it. But again, if you are done with the third normal form, you are done with the normalization process. These things means when you are in a third normal form and you also doesn't have any multi-value dependency. Imagine this table, okay? Faculty name, committee is admission, scholarship, course, IM 101, IM 101, okay? So technically we can say for the faculty name and the course, there is two value. So there is a multiple value dependency. So in that case, we can also decompose this table to the faculty committee table and faculty course table. So that's it. Again, fourth normal form is not a big deal. The most important one is the third normal form. When you are in the third normal form, you are good to go. Okay? So we are done with the normalization. So let us start working on some assignments, and then we are done. But before going to the assignment, any questions so far for the normalization process? What do you think so far about the normalization process? Is it a friendly process? Good. So let's okay. So let me just answer. So when you go to the chapter 3rd, so in the normalization process, make sure to read the text. So we have assignment 3.1. Okay, so let us start some of them together. Just let me share my screen. Okay, so I hate this one. Okay, so assignment 3.1, functional dependencies test. In this table, the capital letters are the attributes, attribute A, B, like a first name, last name, all the information. And these are the lowercase also, these are considered as a date. Okay, so we want to check the functional dependencies in this table. So let's start with the first one. Column A determine column B, true or false. When we are talking the determining, which means if we have the value of A, we can determine the value of B. Okay, so column A can determine column B or not. No, why? Yes, why? We have one no. Why? Mm-hmm. Okay, what do you think? What do you think? True, why? Primary key, sorry?
Usually on all the way to the left.
No, that's not the case. No. No, that's not the case. Is it true or false? Okay. If A, B. If A is A1, what is the related value? B2. If it's A3, what is the related value? B2. If it's A1, what is the related value? B3. If it's A2, what is the related value again? B3. Maybe because this is A and B, you are not okay with it. The answer is false. Because for one value, we have two different values. That's correct. Okay, let's consider it in a real example. The first A is the customer ID. Okay, the B is, for example, the SSN of the customer. Okay, customer ID 1, which is Hossein Mohit, that's the SSN for Hossein Mohit. Okay, again, we have customer 1, which is Hossein Mohit, but this time we have different value for the SSN, which is not right. Am I right? Correct? Now make more sense probably with the example. So technically for one value, you should have a unique value in the dependent column. Okay, so that's why this one is false. Now let's go to the second one. A to C. A determines C or C is dependent to the A. Now you tell me, is it true or false? A to C. Let's write together. When I have it A as a A1, what is the value for C? C1. When it's A3, C3. When it's A1, C1 again. When it's A2, C1. It's fine. Okay, so here we can see that for A1, we just have one single value. Maybe now you are just thinking about the SSN example, which is not a okay example for this, because if you consider this one as a SSN, so technically the SSN should be only unique. But imagine, for example, this is the state. Customer ID1 only lives in Georgia, which is I am. Okay, so there could be another customer that also lives in Georgia, which is fine. Okay, so right now we can say this one is third one, A to D. False, because for A1, for customer ID1, there are two different values. One D3, one A3, one D1, right? If you might make a mistake, so just write it. A1 once is D3, once is D1. There is two value for one single value. It is not right. In this case, remember the SSN example. For the Hossein name, there is a two different SSN, which is not right. Okay. For the previous one, remember the estate example. Hossein can live in Georgia. You also can live in Georgia. Okay. And so column A determine E. You tell me. True. A1, E2, A3, E4, A1 again E2, A2 is E2, which is fine. Okay, so true. And the rest of the questions is related to consider the possible primary key. Is column A is the possible primary key for the table X? If in order to be in a primary key, all the values should be unique. Simple. This is not unique. There is two A1, so this is not okay. But the only one that is okay for it is the D, which is D2, D3, D2, D1, D4. So there's a unique value for it. So technically, 6 questions already answered with this one. And the last one, the last type of question is the taken together. Column B and D are the possible key. So you should also consider the both. So this one could be the assignment 3.1. And 3.2, in this case, each relation that you are seeing here, this is the schema version. So this is the employee table with the employee ID as a primary key and the rest of the rest of the attributes. So you need to find which normal form this table has it. Is it, for example, maximum, it has a first normal form, or no, this one also has the second normal form or the third normal form, or none of the above. So for the first table, what do you think? Employee ID, name, address, phone, skills. So first answer me, please. In order to be in a first normal form, what is the condition? What is the criteria? Atomic value. So we shouldn't have multiple values in the table. So first of all, do we see any values here? No. So the question just want ask you to just imagine if this is the table and there would be some extra information here, which one would violate it? Would be violated. Okay. So according also to the example that we had, for the skills table, there is a possibility to have multiple skills. So technically, when there is a possibility of having multiple in the table, so we can say we are violating the first normal form. Okay, I'm designing this table and give it to you as a person that are entering the data. I am giving you this opportunity to make a mistake. This is the skills table, a skills column, and you will go through the employee resume and you will see multiple skills. So you just normally enter all the skills for each employee. Okay, so technically you are violating the first normal form. Okay, does it make sense? Yes. So technically, when we are not in this first normal form, we are not going to check for the rest. Technically, this is the none of the above. Yes.
What about something like the whole screen?
Because it's one value, yeah. But skills is multiple. Also for the phone, could be cell phone, could be work phone, could be also multiple values for it. Not just the skills. Phone is also could be related. Right? And no, even the address is the issue. Maybe it's a home address, maybe it's a work address. It could be. But at the end of the day, technically, this is obvious. In this table, there's an issue. And also, there is another issue in this table. What is the issue? The functional dependency is here. Phone determining the address. Is phone the primary key? No. Also violation of the third normal form. Okay? So none of the above. This table. Worker ID, worker name, spouse social security number, spouse name. In the worker table, there is a functional dependency in this table. If you have the spouse social security number, you can determine the spouse name. Am I right? Is the spouse social security number is the primary key? No. Violation of the 3NF, third normal form. Okay, so far we know that this table is not in the third normal form. What about the first normal form? Yeah, it is okay because there is no possibility to have multiple values for each. So this table is in the first normal form. And for the second normal form, there is no composite key, so we can say this table is also in the second normal form. Okay, so the answer is second normal form. Let's see this table together. Sale table. We have composite key, which the keys are date, customer, and product. Okay. Vendor city, sales representative is the non-primary key. Okay. So there is a functional dependency here. Customer determines sales representative. So sales representative dependent to the customer. Customer is part of the key. Sales representative is not dependent to the whole key. It's just dependent to the part of the key. So we are violating the second normal form. Okay? And also, For the rest, we are also violating the third normal form because again, these two, this one is determining the not the whole key. But the first normal form could be okay. Each of them can have a unique value, can be atomic. So this one, the answer is first normal form. Good. So that's the whole normalization process. When you design your database in a normalized way, in future, you are not gonna have any issue with the data redundancy, all the anomalies and issue with the updating, deleting, and inserting data. Okay? Any question? All good. Whatever I mentioned was clear. Really? Am I good enough? Good. So one more time. Monday, no class. Let me stop recording first.